And further, what we have done is we have written a very simple sequential C program, right? So the first lab session we wrote simple input output programs where printf, scanf we have used the built-in library functions. Apart from that, we use some mathematical operators which are provided by the C language. Now, this week we'll go ahead and we will explore the conditional statements which are provided by C. Okay, so actually I am going to talk about operators as well in detail. So there's a rich set of operators which C provides. But I'll leave that to another lecture because right now I just want to speed up so that our lectures match with the lab session that we have. Okay, so I just want to go a step further before, and then I'll come back and revisit the operators in detail. Okay, so for today's lecture, this is the outline. So we'll be looking at conditional statements in today's lecture, the conditional statements which C provides. Okay, so this is a part of what is known as control structures that we have. So control structures basically are programming constructs which actually help you to modify the flow of a program. So you want to modify it depending on some condition. So modify depending on a condition. So the program that we wrote in the last week was sequential in nature. One after the other, we were executing the program statements. We were writing the program statements. There was no concept of a condition as such. But many a times, what we require is we require the flow of the program to change depending on a condition. So if a condition is true, I want to do something. If the condition is false, I want to do something else. So that is the idea. So we require control structures to solve real world problems very often because sequential flow is not what is seen. Everything happens on the basis of a trigger, on the basis of a condition in the real world. Okay. So without wasting much time, let's move ahead and see how do we actually what is the interface which C provides so that we can write these conditional statements. Okay, so we start with a simple logic expression. So what is a logic expression? It's basically a condition, nothing but a condition, and we have what is called as a logical operator, logical operator in C. So logical operators that are there in C basically are less than, greater than, you can see here, less than, greater than, less than, equal to, greater than, equal to, double, equal to, and not equal to. Okay, the meaning is mentioned here. So this is simply less than, greater than, less than, equal to. Here if you see a double equal to, okay, a double equal to operator means it is checking for equality. So basically logic expressions are nothing but they are conditional statements, and we are expecting a true or false kind of value from the expression. They evaluate to either true or false. So these operators, whenever you want to construct a logical expression in C, then in that case you need to make use of logical operators. Okay, these operators are also known as relational operators. So you'll see the word relational or logical, both mean the same. Okay, so you need to use these 6 operators so that you do some kind of a comparison basically. So understand there are 2 operators in C. One is the assignment operator, which is a single equal to. This is the assignment operator. Understand the difference. And this double equal to that we have here is an equality operator. So it is going to, it's a logical operator. It's going to check whether the expression, whether the left hand side is equal to the right hand side or not. So we'll see how to use it. The prototype or the syntax is given here. Data, operator, data. So on the left hand side of the operator, you have some data. On the right hand side of the operator, you have some data. So examples are given here. So for example, A and B are two variables with these values. Then this is the result of all the 6 logical operators. So so it's basically asking a question, and the answer to that question is either yes or a no, true or false, right? So is A less than B? Yes, right? So it evaluates to true. Is A greater than B? No, right? Are you getting this? Are you getting?
Ma'am, can you show the last slide once?
Yes.
Okay, ma'am.
So are you getting the expression how it is evaluated? So for example, see the last and second last and last. Is A, the question reads, is A equal to B, right? Is A equal to B? No, right? So the answer is false. Is A not equal to B? True. A is not equal to B, right? The examples are clear, right, everyone?
Yes, ma'am.
Yes, ma'am.
Okay, fine. Next is a complex. So what we saw earlier was a simple logic expression. Next, we move on to make it more complex, because that is what we require very often. And that is nothing but you make use of an additional operator for combining the expression. So you have multiple logical expressions which can be combined by some additional operators. Okay, and these operators are and, or, and not. Okay, so two conditions. So one is true, the other is false. You want to combine them. You want to check the truth value of both the conditions together. So you can combine them using either the and or the or the or you can use a not also to just flip the condition. That can be done. So if you want to combine, you use and or. So for and, everyone knows the and truth table, right? So when the value of
Yes, ma'am.
left, yes, so when the value of the left expression and the right expression is true, both are true. The result is true, right? Any one of the expressions, if it is false, any one of the expression, if it is false, the result is false, right? This is and. The or, on the other hand, is any one should be true, then the result is true, right? Only when all the logical expressions that it is combining is false, are false, then the result is false. Okay, so the symbol for that is double ampersand for and. This is the symbol in C, right? uh, Two pipe symbols for or, and this exclamation mark for not. Okay, these are the operators which you have to use for writing the expressions, for combining expressions, or writing taking the negation of an expression. So again, given examples here. So these are the values of x and y. So how will you use and? So if you're saying is x less than 4 and y less than 8, the result of this is true because both expressions are true. Okay, both the expressions are true, right? Looking at the values of x and y, both the expressions are true. So the
Yes.
result is true. Okay. Similarly, um, for this is true, but the other one, this one is true, right? Is x greater than 3? This is true, but this is false, right? So true and false will be false, right? What about this? Just go through the examples. I'll give you 2 minutes. Just go through the examples. Tell me if you do not understand any example. So look at the last few examples where the not operator is used. See how do we use the not operator, right? So I just want to give you one comment here that and or, right? The pipe symbol they are binary operators, right? What is the meaning of binary operators? What do you understand by binary
Two
operators?
operands it has.
Correct. So they work on two operands. There's a left hand side and a right hand side, but not is a unary operator, right? Because there is only one operand on which it is working.
Yes, ma'am.
Okay. So I hope the expressions are clear, how they are evaluated. Everyone, please let me know. Any doubt
Yes.
so
Yes,
far?
ma'am. Got it.
मैम ये समझा नहीं मैम
Okay.
बाइनरी ऑपरेटर्स वगैरह
What you didn't understand? Binary operators.
यस मैम
Binary operators are operators which require two operands for it to give you a value. For example, and. So and has some expression on the left hand side, right? Expression on the left hand side and some on the right hand side, right? So it will require two operands. It's working on two operands. In this case, the operand is an expression. It's a logical expression because it's a logical connective, basically. Fine. On the other, similarly for or also is the same thing. This is or. This is the pipe symbol that you see on your keyboard. Two pipes, right? So similarly for or as well, it will require two expressions. One on the left, right. On the other hand, the not operator is a unary operator because it takes only one expression. No? It works on only one expression. Okay. Are you getting it?
यस मैम थैंक यू मैम
Yeah.
Ma'am, how to
Yeah.
type the pipe symbol on computer?
Yes. So it is basically there on your keyboard, above, forward, backward slash.
Okay. Yes, yes, there is.
There is, yeah, that is one pipe. So twice you have to type it. That will give you the logical or connective. It's a connective, right? They're connecting two expressions. They're also known as logical connectives or an and. Any other doubt? Okay, let's proceed. So this is just an example of how to evaluate it. If you're very new to programming or very new to logic, okay, Boolean logic, I hope everyone has done in math somewhere.
Yes, miss.
Yes,
So
ma'am.
Yes, ma'am.
यस मैम
yeah, so you can just go through it. It's just telling you how it works, okay, using the tree and all that. If it's in case if it's a very complex expression, then you can do this. You just keep on replacing it by false, true, okay, and then it works. So you can just go through this. I will send the slides to you. Don't worry. Okay. Now we have seen uh, the way we express a logical expression in C. We have also seen to write a complex one. Okay. Now this logic expression is important because this comes as a part of the conditional statement. Okay. So there are two types of conditional statements which are available in C. One is the set of if statements, and there are variants. There are variants of this if statement. Okay, there are two types broadly. One is the if statements and one is the switch statement. Okay, so these two are keywords. These two are keywords or reserved words, right? They are part of the syntax of C. They are reserved words or keywords in C. They are the basic types. They are the broad categorization of conditional statements. Okay, now when we look at if, there are three different types of if statements. First is the plain if. Okay, next you have if else. So plain if is it's simply that if the condition for if the condition written along with if is true, then some set of steps need to be followed. Okay, that is if. And if else gives you an alternative path to be executed if the if condition is false. If the condition written along with if it is false, then you and if you want to do something else, then in that case you have an if else. Okay, we will see each of these. And finally, there is a nested if. That means an if inside an if. You can write an if statement inside an if statement, and that is nested if. So these are the three variants. We will, don't worry, we'll see the examples and what it means, what is the syntax, we'll see, okay, in detail. So three variants. So first is the if statement. So if you look on the right hand side, you have this flow diagram which actually depicts the if statement. So you have, it's similar to a flow chart, right? So where you have the condition in the condition box. Okay, if this condition is true, then do something. This is the syntax of if statement. There is no otherwise here. So there is no otherwise, you have to do something else. If this is false, do something else, no. But if it is false, it simply comes out of it, and whatever is there after it will execute. Whatever is there outside the scope of if, it will keep on executing in that sequential fashion. Now, what do I understand by this? Let us see the syntax. Syntax is here, given here. Syntax or the prototype. The prototype, wherever I've written prototype, it means the syntax in C. Okay. So the syntax is if into parenthesis the expression, which expression? The conditional expression. Okay. The expression, and then statement, followed by statement here. Okay. After this, there's no else here. Are you getting it? There's no else here. So whatever follows this statement will be executed anyway. It is going to be executed anyway after if is executed. Okay. Only if the condition is true, this statement will be executed. Only if the condition is true, this statement will be executed, whatever is written here. Now it is possible. So if you look on the right hand side again, this is what it depicts. So if this condition is true, execute this statement. Okay, so just to correlate, the line numbers are written here. So if this condition is true, or line number 2, right? If it is true, then this statement is executed. Okay, and of course this means false, but there's no special condition of special statement as such written which will be separately executed if the condition is false. Okay. Similarly, if you have more than one statements which you want to execute, in case of an if, then you have to put those statements inside what is known as a scope or a curly bracket. So in C, this pair of curly brackets, it is known as a scope, okay, or a block. It's a block. That means if you have multiple statements that need to be executed, okay, if this condition is true, then you put that inside curly brackets. If there's a single statement that you need to be needs to be executed, then you do not need to put the curly brackets. But if there are multiple statements, if the condition is true, then you need to put curly brackets. Now this will not make much sense unless and until we see some example. Okay, so we'll look at the example. So for example, very simple example, two values you are taking from the user, scanf A and B, two variables. Okay, and you're writing this kind of a statement. So what you're doing is you're checking whether B is greater than A. So if B is greater than A, then in that case, you want to print this statement that B is larger than A. Okay. And then you want to simply say that your job is done, your program is done. So this is your usual sequential statement that you have here. Okay. So you write it as this, if into parenthesis, the condition, and then you say printf B is larger than A. Okay. This was an example of a single statement. But what if there are multiple statements that you need to execute when the condition is true? Okay, the condition is true and you want to execute multiple statements. So in that case, what happens is you put those multiple statements inside a block, the curly brackets. The curly brackets will help you there. So you put, there are two statements that you want to execute in this example. First is A is smaller than B, and second is the difference is B minus A. These two statements you want to execute. Both of these you want to execute. Then you put these two statements inside curly brackets. Okay. And then this is the usual flow after this, and you print the done. Yes, statement.
Ma'am,
Yes, yes.
we use the backslash and when we want to print it on the next line, right? The escape sequence.
Yes, yes. This one.
So why is the so why is backslash and at the end? I mean, whatever is there after the backslash and that should come on the next line.
So
And
this
there
will
is
what
nothing.
will okay, this will what will this do is the prompt which is there, na? The prompt will come on the
Yes.
new line. Otherwise, if you notice, if you don't put this backslash in, the prompt will come here only somewhere after this statement. So it will print like B. The output will be like B is larger than A or whatever. Okay, then new line again is there, and then it will print done. And then the prompt blah 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 C drive whatever na you get here only.
Okay, so
You
the
get.
backslash n is there for the prompt after that.
No. If I don't put the backslash in the last statement, then the prompt that comes back now after your program is
Yes.
executing, you're executing it from the command prompt, right? So
Yes.
that will come on, that will be on the same line.
Okay, I understood that now. Okay. Thank you.
Yes.
मैम
Yes.
मैम सपोज अगर बी अगर ए से छोटा रहता तो फिर कैसे?
हाँ, let us understand that. So the B,
Ma'am.
so if this condition is false, let me answer this question, then I'll answer yours. Yes. Okay. So if B happens to be, so if this condition happens to be false, then this will be printed. Then this will not be printed because the condition is false. So it will not go here, right? It will not go here. It will simply move on to, it will simply continue executing whatever is there after it. It will simply continue executing whatever is there after the if statement. Okay?
Okay.
You will, now when I talk about if else, you will understand what is the difference now between if and if else. Let me come to if else, then you will understand the difference. Yes, next question.
Ma'am, is it okay if we put curly brackets for even a single statement?
Yes, good question. So what if I put a curly bracket this here, right? Although it is a single statement, it is allowed. Okay, but curly bracket is required. It is required if you have multiple statements. So for example, if you do not put the curly brackets here, if I don't put the curly brackets here, then what will be the problem?
The computer will consider only the first statement as the result if A is less than B, not the second.
Very good. So what happens is this will treat it as the first case, right? So it will treat it like I want only, it will assume that I want only the first statement to be printed if this condition is true. Okay. So let's say A is 3 and B is 4. The condition is true. It will print this. Okay. Then it will come here and print it. And then it will come here and print it as well. But it's not happening because of this. Okay. Now suppose if B is 4 and B is 3. So what will happen? The condition is false. Condition is false, right? If A is 4 and B is 3.
Yes, ma'am.
The condition is false. Now, if the condition is false, it should not print these two. It should not print these two, right? If the condition is false, it should not print these two statements.
Yes, ma'am.
But what will happen? It will ignore this statement. It will ignore this first statement since I have not put the curly brackets. Just assume that I have not put the curly brackets. And it will print this and it will print this, which is wrong, right? It should not happen. Only done should be printed. Yes or no? Logically,
Yes.
only done should be printed. Okay, so that is the problem. Are you getting it? If I miss the curly brackets, what happens? Although
Yes, ma'am.
if there is a single statement, you can put the curly brackets. So most of the students, when they are new to programming, they have this habit of putting the curly brackets lest they forget it, because when they have multiple statements, you get confused. whether I should put it or no. Okay, so many people put the curly brackets in either case, so it's fine. But the first case, it is optional. Fine. Is it clear?
Oh,
Any other doubt?
no.
Okay, let's proceed. Next is if else. In the case of if else, what happens is you have the sequential flow followed by the condition. So if the condition is true, it executes something. If the condition is false, it executes something else. And then after doing this or this, either this or this flow, so the flow will either go this way, right? And what will happen? And it will start executing whatever is there after it. So this is one flow. Either this flow it will follow, or the alternate flow will be this, right? This flow. The flow will be either from on what is seen on the green, or what is there on the red. Okay, that is what is if else. Okay, let us see the syntax. Syntax is simply, okay, if condition, and if the condition is true, then you have a block of statements. So we have put the curly brackets here. Now whatever you see here in this example is basically an if else. We call it a ladder. We call it an if else ladder. Okay, so if the condition is true, you do something else. You do something else. If second condition is true, you do something else, and so on. So I will talk about if else variants first. So if else, the first variant is this, what you saw here, the very basic one. So you have only two parts, if and else. Okay, that's a very basic variant. Okay. So it's something like what is there here. Okay, so how do you write it? It will be something like if I'm taking the same example, if A is less than B, print F true, else, see, now I have put in curly brackets, it is not required, curly brackets, it's optional, else false. Okay, this is my example. So how it will work? Simply, if the condition is true, it will go inside it, otherwise it will print false. Okay, and then it will continue with the execution. That is the example of this flowchart. But what if I have multiple conditions which I need to check? So for example, if you want to find the grade of a student, so there are ranges, right? So if it is above 90%, then it is say O grade, then between 85 90 it is A grade, okay, and so on. So there are multiple conditions that you need to check. So in this case, you need to go for what is known as an if else ladder. Okay, so in case of if else ladder, what happens is you have if condition, and in the else part you have again one more if. Okay, so else if, so instead of if and else, you have if condition 1, do something, else space if condition 2, do something else. Okay, again third condition, else if condition 3, do something else, and finally else, do the last. So if all these conditions are false, do the last thing. If all of these conditions are false, do the last thing. Okay, so in this case the flow is given here. How it works, something like this. Have you talked about this conditional flow in algorithms, flowcharts? You have come to this or no?
Not yet.
Not
Not
yet.
yet, ma'am.
No, ma'am.
Yeah, so basically if this condition is false, then it checks for another condition, right? See, if the condition is true, fine, it will execute whatever is there. Otherwise, if the condition is false, it's checking for another condition, right? It's checking for another condition, condition 2. If this condition 2 is true, then fine, it will execute what is there in B. It's this flowchart. This is depicting what is there on the left hand side, by the way. So A, B, C, D, you see. Okay. If otherwise, if it is false, then it is checking for the third condition. Okay. Now the third condition, if it is true, it will run C. Okay. Otherwise, it's checking for. Otherwise, it's going to the else part, final else part, and whatever is there in else, it's going to do that. That is D. Are you getting the flow of it? If else ladder.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And after everything is checked, so this is the entire thing. All these conditions are checked one by one, one by one, one by one. And finally, what happens is whatever is there after it will be executed.
Ma'am,
Yes.
if there is true, and can there be conditions further?
Okay. Good. So what happens is if you look at the flowchart itself, it tells you that the moment it becomes true, it's coming out of it, right? The moment this first condition becomes true, it's running whatever is there in that scope and coming out of it. Here, right?
Okay.
The moment second, okay, suppose this is false. So the moment the second condition is true, it is running this and it is coming out of it, right? So it's not going to check for anything else. That is how it works. So it will be only one of these will be checked. The moment a condition becomes true, if else gets you out of it. Is this clear?
Okay, ma'am. Yes, thank you, ma'am.
Hello, miss.
Yes.
Miss, I have one doubt. Miss, if the condition is true, but we want to check another condition, then how is it possible?
If the condition is true and if that condition is true, then I want to check another condition, right? That is your
But
question.
still, we have to check. But, huh?
So then you need to make use of a nested if. You need to write. So here when you come, suppose this condition is true, okay? Suppose this condition is true. So here inside the scope of this, you need to check for another condition. Some inner condition. So that is nested if inside an if, right? It's inside the scope of this if. So that is nested if.
Okay.
So this is the example for the grade. Okay. So you can just correlate it with your grading system and then change this example appropriately. Okay. So this is, you're taking the grade from the user and you're trying to give, actually you're taking the marks basically, or the percentage, and then you're saying the GPA is so and so. Okay. So A, B, C, D, whatever. And then none of these, then you're failing. The person is failing, right? So GPA is F and unsatisfactory. So it's a simple example which depicts the if-else ladder. So if condition printf. So there's a C. You'll see in the first few conditions, all the conditions in fact, except for the last else, they are single statements. So we have not put curly brackets. It's not required. It is optional. Okay. So you are printing A, otherwise you're printing B, right? This is the syntax. Now, the thing is, in any language that you're studying, in any programming language, you need to practice, okay, writing with the syntax. Otherwise, you will not get used to it. So you need to write these programs very often. So I'm going to give you a list of simple programs which you'll practice for if else only, for if else. Very simple programs so that you get a hand on it. Okay. I'll send that list on Classroom. I will upload it on Classroom. For those of you who are new to programming, you should practice it. Is this example clear?
Yes, ma'am.
Yes, ma'am.
Any doubt? Anyone has any doubt still? You can ask. Okay. So coming back to your question, which was asked again, I told you the answer is nested if. So you need to check one condition within another. So in that case, you need to make use of nested if. So this is how the syntax looks like. Okay. So if you see, this is the outer if and this is the else part of it. Okay, and inside this if only, if the condition is true, you need to check for something else. Only if the condition is true, you need to go inside and check whether these conditions are also true. So if this condition is true, okay, so this is showing. So first condition, expression 1, right? If it is true, it is going inside this green block. If it is false, it's going in the red block. So in the green block, again you have if. Okay, so if so first you have a statement A, some statements, set of statements A. Okay, once they are executed, then there is a condition which needs to be checked. So that is condition expression 2. And if that expression 2 is true, then you have a set of statements B which will be executed. Okay, otherwise if it is false, then you have a set of, then you have C, and then you have, after C you have one more if. Are you getting? Nesting can go deep and deep. It does not matter unless and until, as far as your problem is concerned, whatever is required, you need to write those many conditions. If your problem statement is that conditional that at every point you need to check for some condition, then you have to write the flow in this fashion. So this is a complicated example. So it's going inside false. Here again inside that there is an if now currently, which is highlighted as yellow on the left hand side. Okay. And then that's a single if which we have used. There's no else there. So after that, there's nothing. So after this gets executed, it will come out of it. Okay. From here, it will come out. Sorry, from here it will come out. And from here also it will come out. It's done. And otherwise, if it is false, the outer condition is false, then it will go to the else part. And what is there inside else? Again, there is a statement E. And then there is an if. Okay, and that also comes out. After you are done with this, it will come out, and whatever is there after this, that will logically execute. That is how it happens. Okay, that is nested if. So this is just a check for how many paths do you have. This is okay. I'm just skipping this. You can solve this as a homework. Okay, these are some, these are just counting how many paths are there. Okay. हाँ. Yes.
मैम वो जो आपने फ्लो डायग्राम, हाँ मैम, वो पर फ्लो डायग्राम बताना.
Which flow diagram? The first one.
नेस्टेड इफ का. हाँ मैम, बस यही. मैम तो इसमें एक्सपेरिमेंट 2 में एल्स इफ लगाया क्या, यानी फॉल्स का भी उसने स्टेटमेंट लिया ना मैम?
Which one?
मैम ए के बाद में जो एक्सपेरिमेंट 2 है,
एक्सप्रेशन 2.
हाँ,
अच्छा ये, हाँ एक्सप्रेशन.
हाँ एक्सप्रेशन. तो सॉरी, वो गलती से हो गया. तो उसमें मैम एल्स इफ लगाया क्या?
देखो, when I say nested if, it can have any type of if else there, if or if else. यहाँ पे मैंने, what we have done is, we have inside this first expression 1, if this condition is true, you're checking for here na, if this condition is true, then do this, else do something else. It is up to you na. It depends on the complexity of the problem statement, how complex it is. यहाँ पे there is an if else. Else if नहीं है वो. This is not else if. See, it is if, else. Inside else there is one statement which is executed, that is this C. And then after that statement there is one condition which is checked. If that condition is true, then D is executed. It's not else if. If else नहीं है ना वो. If else if नहीं है. This statement C is there na in between. See, this statement C is there in between. If else कैसे होता है? How is it? If condition, else if, यहाँ यही आएगा, else space if, condition 2, right?
हाँ मैम.
हाँ, वो नहीं, if else नहीं है. If it is only if. There's a statement followed by that. There's an if. That's it.
Okay, ma'am. Yes, ma'am. Thank you, ma'am.
Yeah. So this is just counting how many paths and all that is there, just for fun. That's okay. You can check it. Next is one example which talks about using if else in your program. Okay, very relatable case study, the ATM case study. So basically, it's simplified here for you that there are three options. So there's an ATM, and you want to write a program to simulate that ATM. Okay, and for that, what happens is you have to start with a menu where you have three options. One is the deposit, second is the withdraw, both money, and third is print balance. Okay, and it is assuming that the balance in the account is zero initially, which is not the case. Okay, just assuming that you're starting from scratch and you're starting from depositing the balance. Okay, you're opening your account, and the first transaction that you will do will be depositing. Okay, and you need to simulate this. Okay, so how will you actually characterize your program? So if if the option chosen by the user is deposit, then whatever is related to functionality related to deposit should take place. Otherwise, if the option chosen is withdraw, withdrawal should be done, right? And finally, if you want to check the balance, that's the third option, print balance. Simplified. It's simplified. There are many more options in the modern ATMs today, of course, but just for example purpose, this is a simulation. You can extend this to replicate what is there. Okay. So first of all, before we start coding, let us characterize our problem statement in terms of input, output, and the formulae which are involved. Okay. So what is the input option? What is the input from the user? What all input data can you get or you expect in the program? First is the option, definitely. Before the option, you cannot proceed, right? The user will enter some option, 1, 2, or 3. Whether he wants to withdraw or he wants to deposit or he wants to check the balance. Okay, that is option. Apart from that, what are the other inputs which are possible? The amount, right, of money to deposit or to withdraw. So that is what is given here. So whenever you're talking about a problem, always think of these three things. First is the input, second is the output, the inputs to the problem, the outputs from the problem, and the formulae which can be used for some computations internally in the problem. Okay, before you go for the algorithm. So output is basically the balance. What you get is the balance that will be there. Okay, you can also have one more output here. What would be that? That would be the money, right? If the user chooses option 2, right? If the user says withdraw it, the output will be money also. Okay, which will be given. So you can have one more variable to recognize that. Are you getting it? So all of these will be input. Actually, this input will be translated to some variables in your program. The outputs also will be translated to some variables in your program. Okay. The formula is balance, simple formula, balance plus deposit if you're going to deposit, and balance minus withdraw if you're going to choose option 2, that is withdrawal. Okay. So this is your simple characterization of the problem. And then this is your algorithm, right? These are the steps in your algorithm. So you initialize the balance, that is balance is 0. You ask the user to choose one of the three options. So you need to give the menu, right? That menu has to be displayed and you need to say choose one option out of these. That is what it does. ATM. Can you visualize the ATM? Press enter or press 1, 2, or 3, whatever. Yeah.
Yes, ma'am.
Yeah. So if the option is 1, that is deposit money, then what are the sub steps for that particular option? Get the amount of money that the user wants to deposit and calculate the balance. Correct? Similarly, for withdraw, it will be the user wants to withdraw. Okay. And This is the formula, simple algorithm. Can you get the algorithm? Can you understand the algorithm?
Yes, ma'am.
Yes, ma'am.
Ma'am, but if the balance is zero, then how will the user be able to withdraw it?
Yeah, so
Because
assume,
we're initializing it to zero initially, right?
yes, yes. So assume that this is your account which is being created from scratch. So the first transaction will be which will be a deposit, not a withdrawal. Okay. So usually what will be the case? There'll be some money in the account, and you will be asked to log in as a user, right? So maybe you will have to enter. So when you put your debit card there or credit card there, you ask for the PIN, right? Enter your PIN. That is what happens. And then from the back end, what happens is your details will be fetched out and your balance will be okay, it's correct. Now it's sufficient balance is there. If there is insufficient, then it will show that error, insufficient balance error. So in the real world scenario, it's a little different. For now, just assume that you are doing it for the first time. So the first time will be a deposit. Okay, fine.
Thank you.
Yeah. So these are the variables. So you must have noticed that in green we have written the variables here. Okay, the balance, the command. Okay, balance is a variable, money is a variable, and command is basically the option that the user is going to choose. Just consider that the user is giving some command to that program. It's commanding the program. Okay, do this, do that, do whatever for me. Okay. So the program is this. So you have your int main. Okay, and you have the these variables. You declare the variables, and then if the so now you need to make use of if. So if the condition, if the command is 1, then do deposit, right? Else if command is equal to 2, do the withdrawal. Else if command is equal to 3, you print the balance. So this is the structure of the program. We have not completed the program. This is the structure, everyone. You must have noticed something here, that is void. Okay, this is actually a way of writing main, because there are two variants of main actually. I'll just tell you right now, but don't worry about this. You can write int main directly also. You do not need to put this void. But there are two variants of main. One which accepts command line arguments. So we do not use that because we are not dealing with any command line arguments. Now, what are these command line arguments? While running the program itself, when you do a GCC, when you do a ./a.out, you are actually going to give some arguments through the command line. You're going to provide some data directly through the command line before the running of the program. Okay, and that is nothing but the command line arguments. So for now, just ignore it. When we'll see one example of command line arguments, and this actually we have given a self study also, so that you explore more on this. We are not going to cover command line arguments as far as the syllabus is concerned, but maybe I'll give you an example or two so that you can learn it on your own. Okay, so this void is just to tell that it is not taking any arguments. It's not taking any arguments. This is one more way you will find some in some cases. I don't know whether you have explored the internet or some books. You will find this void written inside main. Inside main as in the parenthesis. Okay, just ignore it for now. Int command money and balance. Okay, and you have, this is the structure, if else if else if. Fine. Now you would simply need to fill what is there inside each of the if. So if command 1, command is 1, command is 2, or command is 3. Okay, so we have here we have written the menu. So we need to print the menu. So first of all, we have a series of printf statements which is going to print the menu. So initialize the balance as 0 for this program. Okay, if you feel that I should have some 40,000 balance there, you can initialize the balance as 40,000 if you want, if you're considering that there is some amount. Okay, or you can ask that balance from the user, but that will not make sense when we talk about an interaction with the user, right? You are not going to ask the user to enter the balance. Are you getting it? When you're talking about an ATM simulation, the balance has to be there. It has to be picked up from somewhere actually. Okay. And that is a backend. So when we see file handling, we'll see that one example on that. How we will integrate the backend with this program, that we'll see later on. Okay. So if the command is 1, you will say enter the deposit money amount and this formula, the formula that we had written. Money is the variable which you're using, right? And you're doing balance is balance plus money. If the command is 2, you're doing a withdraw amount, you're doing a withdrawal, and you say balance is balance minus money. Otherwise, if it is 3, you simply say what is the current balance. So that this is what happens, right? You just have to assume that the first transaction that the person will make is a deposit. Okay. What if so what happens is what is the problem so far now?
Can only choose one option. After that, it's done.
Yeah. So what will happen? So if you have something like 0 and if I choose I choose withdraw, it will not make sense, right? So it cannot, I mean, I can simulate it for that long. So I need to actually put these 3 things, these conditions inside a loop. This has to be repeated so that I can have multiple transactions in the same for the same user. Okay, otherwise it will not work. Now balance is 0. I can only do deposit here.
But it will show the balance in negative value.
No, it will show 0 because it will not. After deposit, I'm not showing the balance here. I'm not doing a printf balance here, somewhere here, right? Or here. So either I choose 1, whatever is happening behind, I am not understanding what is happening. It's just doing that first thing. So if I say deposit, so it will deposit. If I say withdraw, it will withdraw. I mean, it will execute these statements. If I say withdraw, it will execute these statements, but it is not going to show the balance. If I want to check the balance again, I don't have an option to go back because my program will end now. After else if, what will happen is it will come to return 0. Done. It's not going to show anything. Are you getting the problem with this code? It's not a full-fledged code. It's just a stuff to show an if else. Okay. Is everyone getting the problem with this code?
Yes,
You
ma'am.
cannot rerun it again and again. Okay. These are the examples which, if it is 1, you are just entering the deposit amount. What is happening at the back end, I don't know. Then again, second example, third example, current balance is 0. Third example, it will show 0 only because once only I can run it. Yes.
मैम वो आपने लास्ट में जो समझा वो नहीं समझा।
क्या नहीं समझा, बोलो।
मैम वो सेकंड वाला कि अगर करंट बैलेंस 0 है तो वो रुक जाएगा करके प्रोग्राम। थर्ड वाला क्यों नहीं करेगा?
No.
एग्जीक्यूट वो।
See. What will happen is there is only one flow. Now I do not have a loop na here somewhere. I do not have a loop which will keep on executing this again and again. Na. What is happening is user will enter 1, 2 or 3. Agree with me? 1, 2, 3. Yes, either 1, 2 or 3. If the user enters 1, these statements will be done and it will come out of the program. The program ends. Agree?
Yes, ma'am.
User may enter 2 also. If the user enters 2, it will do this. It will come out of the program. It's not helpful. The program is not helpful at all. Any option which the user enters, it's not helpful. Okay. What if user enters 5? What if the user enters 5?
Ma'am.
None of the conditions are true?
No, ma'am.
None of the conditions are true? Yes. So we have to
give an initial balance also, some 5,000 something.
still it is not useful. Even if I give 5,000, it
Error आ
will
जाए.
run only once. See, usefulness means it will run only once. It will not keep on continuing. Na? Do you want to continue? ऐसा कुछ रहना चाहिए ना उसमें. See, after deposit, it should show me the balance. Okay. Print balance, I need to choose the third option. It does not show me the balance here. It will show me the third option. I have to choose the third option. How will I choose the third option? Only if I get the menu again, na? Only if I get the menu again. I should have one more provision to enter more data. I need the provision to enter the data again. Yes or no?
Yes, ma'am.
Yeah. So for that, the second thing, one is the loop, which is missing here, and second thing is the validation check. What if the user enters 5? So in that case, I need a prompt now from the system. Okay, you're entering something which is wrong, which is invalid.
So, ma'am, can we put a else statement?
Yes. So it's still incomplete. So you need to put an else for that, and you need a loop for actually making it useful. Okay. So I'll stop here. So this actually puts a else, but still it is not complete. Okay. If 1, 2, 3, and the else is error choice, you have entered something wrong. Okay. So still it is not complete. We will revisit this program when we talk about loops. Okay. Tomorrow I am going to take the lecture again. Tuesday I am going to take lecture 9 o'clock. I'll be continuing with this discussion. I'll talk about switch statement, and then we'll switch to move on to loops. Okay, so that you are at least in line with what is to be done in this week. Of course, some of you have already the lab today, but we can't help it. At least you have got idea of if, then you can start with the loops. Okay.
Yes, ma'am.
So tomorrow, hopefully, we'll cover loops, and then we can move ahead. You will have the entire week to complete the program, anyways. Right? Next time you will have to submit it.
Okay, thank you, ma'am.
Yeah.
Ma'am, this is homework.
Thank you, ma'am.
What?
Is this program homework?
This program is not homework. This program is there in the slide, na?
Okay, then what's the homework?
There is no homework. I said homework means I have given some few examples and all are there. Just go through that. That I'll upload now, na? This slide I'm going to upload right now.
Yeah.
Okay.
Got it.
You go through the slides, and tomorrow I will continue with loops. Switch
Okay,
statement plus loops. Okay.
Okay. Thank you.
Yeah.
Okay, ma'am. Thank you.
Bye, ma'am.
No problem. Yeah.
Ma'am?
Bye.
Thank you, ma'am.
Yes.
Hello, ma'am. In this assignment, in some assignment that sir gives us questions which are not taught here. So how